Hello to all my viewers. This is Dr. Dhaval Maheta, and today we are going to understand how to run multinomial logistic regression in SPSS. Multinomial logistic regression is a type of a regression analysis used when the dependent variable is categorical with more than two labels or outcomes. It extends binary logistic regression to handle multiple categories. In case of binary logistic regression, we are having two labels of the dependent variable. While in case of multinomial logistic regression, we are having more than two labels in dependent variable. In multinomial logistic regression, the dependent variable is nominal, that is categorical, with more than two categories. For example, it could be a choice among several brands, types of transportations, or outcomes in a survey. In multinomial logistic regression, independent variable can be continuous, categorical, or a mix of both. They are used to predict the probabilities of each category of the dependent variable. Some applications of multinomial logistic regression in various fields. We start with marketing. Multinomial logistic regression can be used to understand consumer brand preferences where the dependent variable is a choice of a brand. Brand A, brand B, brand C. Independent variables such as price, quality, and advertising exposure are analyzed to determine their impact on brand choice. This method helps companies identify which factors most influence consumer decisions and tailor their marketing strategies accordingly. In healthcare, multinomial logistic regression is applied to predict the stages of a disease, with the dependent variable being the disease stage, that is stage 1, stage 2, stage 3. Independent variables like age, lifestyle, and medical history are used to estimate the likelihood of patients being in each stage. This information allows for more personalized and effective treatment planning. Public policy. In public policy, multinomial logistic regression evaluates the impact of policy changes on various outcomes. The example is improved health, crime reduction, or there can be no change. The dependent variable represents the outcome, while the independent variables like policy type, implementation level, and demographic factors are used to assess the effectiveness of the different policies and guide future decisions to the government. Next is politics. Multinomial logistic regression helps to analyze the voting behavior where the dependent variable is the choice of the political candidate or party, candidate A, candidate B, or candidate C. Independent variables such as age, income, and education level are examined to understand how demographic factors influence voter preferences. This analysis assists in designing targeted campaign strategies and understanding electoral trends. Urban planning. For urban planning, multinomial logistic regression is employed to predict travel mode preferences where the dependent variable is a mode of transportation, such as car, bike, public transit. Independent variables like distance, cost, and convenience are analyzed to forecast transportation choices, which aids in effective planning and development of transportation infrastructure. Finance. In finance, multinomial logistic regression models investors' choices among different investment options such as stocks, bonds, real estate, where the dependent variable being the investment choice. Independent variables such as risk tolerance, financial goals, and market conditions are used to predict investment preferences, guiding financial consultants in developing tailored investment strategies. Now we will take one case study. In an election cycle, understanding the voter preferences is crucial for campaign strategists and political analysts. This case study focuses on predicting voters' preference among three presidential candidates. The candidates are George Bush, Barrett, and Bill Clinton. Remember, this is just a hypothetical data. The dependent variable is categorical with three outcomes. Bush, given the code 1, Barrett, given the code 2, and Clinton, given the code 3. Each respondent provided the information on their presidential preference. So, the preference of each candidate, their age, convert it into age category, education, convert it into the degree. So if anybody has completed the education till 12th, that is a 12 year of education, we give the name high school. 17, bachelor, and if it is 19, graduate degree. We have also captured the gender of the respondent. Now let's see how to run this in SPSS. So same data set is available here. Now I'll go and analyze regression, multinomial logistic regression. The dependent variable is vote for Clinton. Now let's see the coding of it. Bush is given the code 1, Parrot is given the code 2, and Clinton is given the code 3. Age categories: 1 for less than 35, 2 35 to 44, 3 for the age group 45 to 64, and 4 for 65 plus. Degree: high school if it is 0, senior high school if it is 1, 2 junior college, 3 bachelor, 4 graduate degree. And here the code is 1 is male, 2 is female. Now when I will transfer the dependent variable here, it will always ask me the reference category. So the reference category is the last category. What is our last category? So Clinton. So the interpretation will be according to the reference category. Definitely you can change the reference category from here. You can make it first, or you can even customize. Now I will transfer the categorical variables into factor. So age category into factor, highest degree into factor, respondents gender into the factor. Now click on statistics, click on goodness of fit, and click continue. There are no changes to be made in model, criteria, options. Keep the things as it is and click OK. So now the output is ready. So we are having 661 observations which prefer Bush, 278 which prefers Parrot, and 908 which prefers Clinton. Demographics: according to the demographics, less than 35, 438 respondents, 35 to 44, 444 respondents, 45 to 64, 617, and more than 65 age is 348. Less than high school 189, senior high school 947, junior college 132, bachelor's in the bachelor's program 386, graduate degree 193. Male 804, female 1043. So we'll start with the model fitting information. Right click, copy, and now we will do the interpretation. So the null hypothesis for this model fitting information is the predictors included in the model do not significantly improve the fit of the model compared to the intercept only model. In other words, the coefficient of the predictors are equal to 0. Intercept only, it means that no predictors have been included in the model, or no independent variables have been included in the model. So we get the value of -2 log likelihood is 439.573. Now when we include the predictors in the model, this is our final model, and this value is 315.981. This should reduce. Now what is the difference between these two is the chi-square 123.593, and the p-value should be less than 0.05. Now how we will write the interpretation? Let's see. As the p-value of the chi-square test is 0.00, which is less than 0.05, so we can say that the difference of the model with intercept only and the final model is significant. Since the null hypothesis is rejected, we conclude that the predictors age, highest qualification, and gender significantly improve the model's fit compared to the model with no predictors. So in this model fitting information, it is necessary that your p-value should be less than 0.05. Next is goodness of fit. This I'll get it from here, goodness of fit. Now let's write the interpretation for this also. In this, we are having Pearson and deviance. We start with Pearson. This statistics tells how well the observed frequency matches the expected frequency under the model. High p-value. This indicates that the model's predicted frequency do not significantly differ from the observed frequency. This suggests that model fits the data and there is no significant discrepancy between the observed and expected values. So in this case, we want that the p-value should be more than 0.05. See, in previous case, we want it to be less. In this case, we want it to be more than 0.05. Deviance chi-square. This statistics is another measure of goodness of fit, comparing the likelihood of the fitted model to the likelihood of the saturated model. High p-value, this one, indicates that the model fits the data well. This confirms that the multinomial logistic regression model is an appropriate fit for the data. P-value should be greater than 0.05. It is desirable here also. Now the pseudo R-square. So in this, we are having 3. Cox and Snell, Nagel-Kerke R-square and McFadden. Let's write the interpretation for this. So the term pseudo R-square is used because these statistics are not directly comparable to the R-square values from the linear regression models. In case of linear regression model, your dependent variable is continuous. While in case of logistic regression, ordinal logistic regression and multinomial logistic regression, your dependent variable is in categories. So we cannot compare the R-square. And that's the reason we use here pseudo R-square. So we start with Cox and Snell R-square. A value of 0.065 indicates that the model explains approximately 6.5% of the variance in the dependent variable. It provides a measure of improvement in the model fit relative to a model with no predictors. This statistics often lower in categorical models compared to linear regression models. It's bound to happen, no need to worry, but 6.5% is very low here. We start with Nagel-Kerke R-square. A value of 0.075 suggests that the model explains approximately 7.5% of the variance in the dependent variable, indicating a slight improvement in the fit. McFadden R-square. A value of 0.033, this one, indicates that the model explains approximately 3.3% of the variance in the dependent variable. This is a relatively small amount, suggesting that while model improves fit compared to the null model, it does not explain a large proportion of the variance. Next is likelihood ratio test. So this is here. Okay, let's write the interpretation of this also. The likelihood ratio test assesses the contribution of each predictor to the final model by comparing it to reduce models that exclude each predictor. As a p-value of the age category is 0.00, this indicates that the age categories significantly contribute to the model. Or in other words, we can say that there is a preference for the presidential candidate according to the age. This means that the age categories are an important predictor of the presidential preferences. Second, the qualification. As the p-value of the highest qualification, this one, is 0.001. This indicates that the highest qualification significantly improves the model. This suggests that the educational attainment plays a significant role in determining presidential preferences. The next is gender. See the p-value? As the p-value of the gender is 0.00, this indicates that the respondent's gender is a significant predictor of the presidential preferences. This implies that the gender differences influence the voting behavior. Next is the parameter estimates. So this is available here. In this, I will get two outputs. Bush compared with Clinton. You will not get the output of Clinton because the Clinton is the benchmark, the reference category. So whenever we will write the interpretation will be Bush versus Clinton. Parrott versus Clinton. So let's write the interpretation now. We start with the first one, which is intercept. It is negative. So anything which is negative, it means that its odds are negative towards Bush, or other words, its contribution is negative towards Bush, or in other words, it is not contributing towards Bush. So let's write the interpretation. In this multinomial logistic regression analysis, Clinton is used as a reference category for presidential preference. The negative intercept suggests that in the absence of other predictors, Bush is less likely to be chosen compared to Clinton. The next is the age category 1. Beta is positive. P-value is more than 0.05 and it is exponentiate beta. So we will write as the p-values of respondents having age less than 35. So this one, code 1, age less than 35. Let's see. 1, the age less than 35. 2, 35 to 44. 3, 45 to 64. And 4, more than 65. So that's the reason we are writing this way. So as the p-value of respondents having age less than 35, code 1, preferring Bush over Clinton is 0.788, which is greater than 0.05. So this one. So it is not statistically significant. In this category of age, the increase in odds of preferring Bush over Clinton is 0.045. It is positive. But the problem is it is not significant, which is 4.6%. How? 1.046 minus 1. So this is 0.046, 4.6%, but it is not statistically significant. Next is age category 2. It is negative. And this is the p-value. As the p-value of respondents having age between 35 to 44, code 2, preferring Bush over Clinton is 0.816, which is greater than 0.05. This one is greater than 0.05. So it is not statistically significant. In this age category, the decrease in odds, this one, decrease in odds of preferring Bush over Clinton is about 3.8, which is 3.8%. How did I got this number? 1 minus 0.962. So it is 0.038, but it is not statistically significant. One simple thing which you have to remember is, if this is positive, it is increase in odds for Bush, and if it is negative, it is decrease in odds. Age category 3, negative. So what does it mean? People prefer Clinton over Bush. So as the p-value of respondents having age between 45 to 64, code 3, on preferring Bush over Clinton is 0.542, right? Which is greater than 0.05. So it is not statistically significant. It is negative. This is also negative. So in this age category, the decrease in odds of preferring Bush over Clinton is 0.092, which is 8.8%. 1 minus 0.912. Now I have explained the concept of odds ratio, exponentiated beta in my video of logistic regression. Kindly refer it. So this is 8.8%, but it is not statistically significant. So we can say that in this age category, the preference is more or less same for Clinton and Bush, because this is not significant. Now the qualification. As a p-value of respondents in high school, see, this is coded as 0. If you recall it, just try to recall this one. Okay, and this is senior, and this is high school, senior high school. So as a p-value of respondents in high school on preferring Bush over Clinton is 0.346, which is greater than 0.05, which is not statistically significant. So we can say that the respondents in high school and their preference for Bush versus Clinton is not statistically significant, or in other words, their preference is same. Highest degree 1, code 1. As a p-value of respondents in senior high school preferring Bush over Clinton is 0.037, this one is less than 0.05, so it is statistically significant, which means that increase in odds of preferring Bush over Clinton in senior high school respondents is 0.367. Now this is significant. This is less than 0.05. It is significant. It means that this the respondents are having this which are in senior high school prefer Bush over Clinton because this number is positive. So which means that increase in odds of preferring Bush over Clinton in senior high school respondents is 0.367, which is 1 minus 0.44, sorry, 1.44 minus 1, which is 0.44 into 100. So it is 44.4%, and it is statistically significant. Next, as a p-value of respondents in junior college, this is positive. Any guesses? Yes, it is contributing towards Bush only. So preferring Bush over Clinton is 0.102, which is more than 0.05. But the problem is the p-value is more than 0.05, and therefore, though this is positive, it is statistically not significant, which means that the preference of Bush over Clinton in junior college respondents is statistically not significant. Now this is positive as well as significant. So as a p-value of the respondents with bachelor qualification code 3 preferring Bush over Clinton is 0.040. It is less than 0.05, so it is statistically significant, which means that increase in odds of preferring Bush over Clinton in respondents with bachelor qualification is 0.403, which is 49.6%. So 1.496 minus 1 equal to 0.496, and it is statistically significant. See, this is positive, 1.496 minus 1, so 49.6%, and the p-value is also less than 0.05. Now, you will not get the estimates. If there are 4 categories, you will not get the estimates of any one. So here you did not get any estimates for age category 4 and highest qualification 4. Similarly, here also you will not get an estimate for gender equal to 2, which is a female. So what will be my interpretation? See, this is positive and the p-value is less than 0.05. So gender equal to 1 is a male. As a p-value of the gender equal to 1, which is male, is 0.00, which is less than 0.05. This one, it means that the male respondents are significantly more likely to prefer Bush over Clinton with the increase in odds by 0.463, that is 58.9%. So 1.589 minus 1, so 0.589. Now the next is the parrot. We have completed for Bush. Start with parrot. This is also negative. So the negative intercept for parrot indicates a lower likelihood of preferring parrot compared to Clinton in the absence of other indicators. Age category 1, as a p-value of the respondents having age less than 35. This is positive, p-value less than 0.05. It means that the respondents in this age group prefer parrot over Clinton. Why Clinton we are considering? Because Clinton is our benchmark category. So preferring parrot over Clinton is 0.00, which is less than 0.05. So it is statistically significant. In this category of age, the increase in odds of preferring parrot over Clinton is 1.706, which is 450.6%. So 5 minus 506 minus 1, 4.506 into 100. Age category 2. As a p-value of the respondents having age between 35 to 44 years, code 2, preferring parrot over Clinton is 0.00. This, it's less than 0.05. So it is statistically significant. In this category of age, the increase in odds of preferring parrot over Clinton is 1.405, which is 4.076 minus 1, which is 307.6%, quite high. Age category 3. As the p-value of the respondents having age between 45 to 65 years, code 3. Positive, p-value less than 0.05. So it's so simple. This age category respondents prefer Parrot over Clinton. So how we will write? As a p-value of respondents having age between 45 to 64 years, code 3 preferring Parrot over Clinton is 0.001, which is less than 0.05, so it is statistically significant. In this category of age, the increase in odds of preferring Parrot over Clinton is 1.031, which is 180.4 percentage. So 2.804 minus 1 is 1.804. Qualification. As a p-value of respondents in high school on preferring Parrot over Clinton is 0.912, which is greater than 0.05, which is not statistically significant. So we can say that the respondents in high school and their preference for Bush versus Clinton is not statistically significant. Highest qualification, code 1. As a p-value of the respondents in senior high school, code 1, preferring Parrot over Clinton is 0.003, which is less than 0.05. So it is statistically significant, which means that the increase in odds of preferring Parrot over Clinton is 0.813, this one, which is 125.5 percentage. So 2.255 minus 1, and that is statistically significant. As a p-value of the respondents in junior college, code 2, preferring Parrot over Clinton. This is positive, p-value less than 0.05. So preferring Parrot over Clinton is 0.013, which is less than 0.05. So it is statistically significant, which means that the increase in odds of preferring Parrot over Clinton is 0.869, which is 138.5 percentage. How? 2.385 minus 1 into 100, and that is statistically significant. Highest degree, 3. As the p-value of the respondents in bachelor's degree, code 3, preferring Parrot over Clinton is 0.027, which is less than 0.05. So it is statistically significant, which means that the increase in odds of preferring Parrot over Clinton is 0.650, which is 91.6 percentage. So 1.916 minus 1 equal to 0.916 into 100, and that is statistically significant. Respondents gender equal to 1, which is male. Male respondents are significantly more likely to prefer Parrot over Clinton, with the increase in odds by 0.757, that is 113.3 percentage, 2.133 minus 1. So it is 113.3 percentage, and that is statistically significant as the p-value, this is less than 0.05. Classification. This is available here, classification table. So I will go in analyze and regression. I want the classification table, so that is possible. Let me check. Click on statistics, activate the classification table, continue, click OK. This is the classification table. Here is it. Now let's write the interpretation. So this is the observed data, and this is the predicted data by multinomial logistic regression model. 198 are such cases in which the respondent's preference was Bush, and the prediction done by the model, it was correct. Parrot observed and the predicted model 0. So the model is not working good for the Parrot. Clinton, observed data 723 and predicted by the model is, so you can say 723 are correctly classified cases. 198 plus 723 are correctly classified cases. 104 plus 185, 4 plus 463 plus 174, they are misclassification. They are known as a leakage in the model. The model did not correctly classify it. So here the observed data was Parrot, but the model predicted Bush. So the model is not working properly. So what will be our interpretation? The model achieves an overall classification accuracy of 49.9%. This means that the model correctly predicts the presidential preference of nearly half of the respondents. So this is 49.9%. The relatively high accuracy for predicting Clinton compared to Bush and Parrott suggests that the model is more effective at identifying preferences for Clinton while it struggles significantly with predicting preferences for Bush and Parrott. So what is our conclusion? Bush versus Clinton. Clinton is a benchmark category. Higher educational attainment and being male are positively associated with preferring Bush over Clinton. Age category shows no significant effect. Parrott versus Clinton. Older age categories, higher educational attainment, and being male are positively associated with preferring Parrott over Clinton. The effects are particularly strong for older age categories and those with higher degrees. So this was all about how to run multinomial logistic regression in SPSS. For more videos on advanced data analysis using SPSS, kindly subscribe to my channel. You can also refer my playlist in which I uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.